Yes. Now coming to additional postulates. In the last class, we have gone through the angles, different types of angles. The most standard angle, the angle between the vertical and the horizontal, which is considered to be equal to one right angle, and in degree measure, one right angle is considered to be equal to 90 degrees. And an angle less than 90 degree acute, greater than 90, less than 180 is obtuse, and 180 is taken to be straight angle, and more than 180 and less than 360 is taken to be reflex angle, and 360 is taken to be complete angle. So, in this particular fashion, we have differentiated the angles, and if the sum of two angles is 90 degree complementary and 180 degree, it is a supplementary. And then we can move to some other angles also, that is vertically opposite angles. And even in case of these particular lines, whenever two lines are intersected by a single line, we may have that corresponding angles, alternate angles and interior angles like that. So they are considered to be axioms or something like that. So now today, afterwards we stated certain postulates, and again we will be continuing with some additional postulates. So if you go through a straight line, every line segment has a positive length. So however, for lower classes it is of not so much important statement, but for higher class, when you deal with vectors, this statement is very important. Because whenever we go through line segment, the symbol is different. Whenever we go through line, the symbol is different. And whenever we go through this particular length, the symbol is different. So if AB, if we put just one bar, it will be a line segment. On AB, if we put a directed line on both sides, it is considered to be straight line. And if there is one endpoint, it is considered to be ray. And if no symbol, then it is length. So if we go through those particular concepts here, say AB with this symbol, what it is? It is a line. And then AB with this symbol is a ray symbol. And then AB with this symbol, line segment, line segment. Then we will be having this particular concept, that is AB is equal to AB, that is length. That is length. So when if we write down only AB, it implies length. And if we write in this fashion, it is line segment. And if we write in this fashion, it is ray. And if we write in this fashion, it is line. It is line. So, and whenever we consider length, length is always positive. So it is most useful in case of physics or something like that. But here, these are not of so much of importance except these particular symbols. Only whenever you consider have this symbol, line segment, this symbol, only we are practicing the symbols, but they have got very less meaning, because here in this case we are not considering about the directions. But when we come across those vectors or physical quantities, this concept will be very important. So here we merely say that AB is a ray. AB is a ray, A will be initial point, B is that is terminating point, but that we will not mention here. So we don't have so much of difference here. But when we consider these as a physical quantity, then the directive concepts are very important. Say means from Athani to Bijapur or Bijapur to Athani, the distance is same. But if we move from Athani to Bijapur, the direction is different. From Bijapur to Athani, the direction is different. So if it is A to B, then it will be from B to A. A is Athani, B is Bijapur. A to B means Athani to Bijapur, and then Bijapur to Athani, then they will be different. See, instead of AB, we will be writing there BA. A Athani to Bijapur, then we will be having Bijapur to Athani. But this particular AB, no different, and this will not at all be different. So you can move in the one direction and opposite direction. There is no difference with respect to length, how much diesel is consumed, the same amount of diesel is consumed in the vehicle. So the length will be always positive. Positive implies it will not be having any sign, because whenever we say positive, then we will be always having in the mind negative, but it is neither positive nor negative, absolute, what we call it as, just like our natural numbers. Then we can move to the other concept. If C is a point, if C is a point on line segment, on line segment AB, so that is AB, on line segment AB, it should be along with a symbol, then what we will get, this particular length AB, this is line segment AB, will be equal to AC plus CB. AC plus C, line segment AB is equal to AC plus CB, or in lengths if you write, AB is equal to AC plus CB. AC plus CB. This is very, very important. This is very, very, very important. When we consider this is also true, but this is C. So the length between A and B is exactly equal to length of AC plus CB. Then what we can say, what we can definitely say, A, B, C all lie on the same straight line, because you may be given 3 points and you have to test whether the 3 points lie on the straight line or not. So what you will be doing then, you will be joining all the 3 points in pairs, and if you add 2 lengths, if it is equal to the third one, they lie on the same straight line. And when we come across this particular triangles concept, if it is the convention here, 3 sides of a triangle are given, and when sum of the 2 sides is equal to the third side, then we will never get the triangle, because all the 3 points lie on the same line. So whenever you want to prove the 3 points to be collinear, then it is the condition, the sum of 2 lengths is equal to the third length. Then we can move to this angular concepts convention. If OA and OB and OC are such that OC lies between OA and OB, between OA and OB, then see, if you draw the figure, how it will be, all will be having same initial point, all will be having same initial point. So this is OA and this is OB and this is OC. So here OC lies between OA and OB, and hence 2 angles are constituted here. One is angle AOC, one is angle COB. Then one more angle is there, that is the big angle, that is AOB. That is the linear sum, what you can say. Then see what will be, angle AOB is equal to angle AOC plus angle COB. Angle COB. So the sum of, that is the linear sum of 2 angles is equal to that big sum. See what it implies, we can add angles also, we can add lengths also, we can add lengths also, but if it is mentioned factorially, we cannot add them. The rules are different there. The rules are different there. Then fourth one, if two rays coincide, if two rays coincide with each other, then the angle between them, is 0 or integral multiple of 360 degrees. Integral multiple of 360 degrees. We are familiar with the clock. Familiar with the clock. See, for example, if we take a specific 0 hours. So when that particular minute hand and hour hand will be at 12, we consider it to be 0 hours. We consider it to be 0 hour. So if you look at that particular clock, if somebody will ask you how many rotations it has taken, no, you cannot predict, because if it is total angle is, then you can divide, but every time you will be having 0, 0, 0. So whenever it covers 360 degrees, it is again considered 0 only. So that is n times or the integral multiple of 360. So whenever those two coincide with each other, only what you can say, the angle between the two rays is 0. Or it might have taken so many revolutions. How many? We don't know. So what we say, merely say integral multiple of 360. So what is that multiple? If you consider n to be the multiple of 360, or what you can say, n into 360 degrees, what n will be? It is an integer. It is not a fraction. So what it can be? 0, 1, 2, 3. It may be 0 into 360, 0, 1 into 360, 360, 2 into 360, 720, like that. So whenever you consider two rays to be coinciding, then the angle between them will be either 0 or it is integral multiple of 360 degrees. So these are the additional postulates. These are some additional postulates. So now after that particular postulate, we can go through one more concept, that is what we call it as proposition. Or sometimes in the earlier or in the old mathematics, they may be stated as theorems or corollaries, like that. Here in the new syllabus, it is stated to be proposition. What this particular proposition is? It is a statement which is to be proved. See, already what we are familiar with axioms and postulates. And axioms and postulates, we never prove them, we take them granted with our experience. But if you go to this particular proposition, you have to prove them. So if you want to prove something, then you will be taking the help of something. If you want to prove that what that particular something is, they are nothing but axioms and postulates. Axioms and postulates, addition point, you will be taking the help of those particular axioms and postulates, and you will be proving these particular propositions, or what you can say theorems. So what these particular theorems or postulates are, these propositions are, they are mere statements which are to be proved. So some propositions can be directly proved, and some is proving there is a reverse method also. There is reverse method also. So let us take one proposition here, or you can call it as theorem also. You can call it as theorem also. So proposition or theorem. Or theorem. So we will be taking the first proposition. If a ray stands on a line, the sum of adjacent angles, is 180 degrees. 180 degrees. So, but in this particular modern books, what they have done, they have stated it in the form of a figure or something like that. But it will be of not so much use, because whenever stated with the figure, you will be always remembering that particular figurative letters only and not the statement. So here I will be writing both the convention. It is the statement. and this statement is true for all the figures. If a ray stands on a line, the sum of adjacent angles is 180 degrees, and at that instant the adjacent angles are said to be linear pair. Or what I can say, see here you can go through that particular so whenever you go through this, you can call it as data also. That is proposition data. A ray OC, stands on a straight line, or on a line, I will be writing in short, on a line AB. See, remember this thing. On a line AB. Line means marking is in this fashion. Adjacent angles, BOC, angle BOC and angle COA are formed. So when you go through this particular statement, it will be having two parts. One will give you the data, and according to the first part, what you have to do, you have to draw the figure, name the figure, and after naming the figure, you have to write down the statement. But unfortunately, in your books, it is given in this fashion only. Probably, I think it is unfortunately. So here, see, because whenever you will not go through, you can say that ray something that washed, or that if you go through that particular line as xy, then what you start feeling, it is a different proposition only. No, this is the statement. So after writing this in the statement, see, a ray stands on a line. So you have to draw the figure. So what you have to do? You have to draw the figure on a line. So which line you have to name it and write here. This is the system and this is the method. So here unfortunately it is given in this fashion only. So we will be marking it as line AB. Then what happens? A ray stands on it. And what is the name of this particular ray? It is OC. Then what are the adjacent angles formed here? One is here and one is here. This angle is BOC and this angle is COA. So what to prove? Sum of adjacent angles is 180. So what we have to prove? To prove. So both these parts, even though you write down, they will be here only. Figure is not given, only the statement is given, and according to statement you draw the figure, and according to the figure you write down this one. Here also I have written it first because it is given in the book in that style only, but the method is like that. According to this one, you draw the figure, you name the figure according to your will, and then according to the figure you write down this particular data, and then what you have to prove. Sum of adjacent angles is 180. So what are those adjacent angles? Angle BOC is one adjacent angle, and angle COA is another adjacent angle, and what that particular sum will be? 180 degrees. So we know that the measure of a straight angle is 180 degrees. Only we have to prove that the sum of these two angles is equal to straight angle. So now we will be having that particular proof. So already you have gone through one postulate, say additional postulate. One angle, one adjacent angle plus another adjacent angle is equal to complete angle. It is an additional postulate. So if OC is common to these particular angles, then what will say? Sum of these two adjacent angle is equal to that total angle. So according to postulate Y, we can say angle BOC plus angle COE is equal to what? Angle AOB. But what that AOB is a straight line, hence it is equal to 180 degrees. So from the figure, what will be saying? Angle BOC plus angle COA is equal to how much? Angle AOB. Angle AOB. What is that? That is additional postulate, or you can call it as rule also. You can call it as rule also. But AOB, what it is? It is a straight line. It is a straight line. What is its meaning? That is angle AOB is equal to 180 degrees. 180 degrees. Therefore, what we can say, angle BOC plus angle COA is equal to 180 degrees. So, the question was there, it was there, no? It is proved. It is proved. So, therefore, angle BOC plus angle COA is equal to 180 degree. Question to be established, QED, sometimes we will be writing in this fashion. So, now here we will be having two statements. What is that? If a ray stands on a straight line, and then what happens? The sum of adjacent angles is equal to 180 degrees. 180 degrees. So, what we will be saying? S is called hypothesis. It is also a type of statement. And what we will be calling that particular result as? It is known as a conclusion. So, now let us take a note for it. If a ray stands on a line, so this is what we call it as S. The sum of adjacent angles. Now, the sum of adjacent angles is 180 degrees. So, what we will call this as R. So, first one is known as S is called hypothesis. Hypothesis is also a sort of statement. And this particular R is what we will be saying a conclusion. So, S is called a hypothesis. H is called hypothesis, and R is called conclusion. R is called conclusion. R is called conclusion. Sometimes what may happen? Conclusion may be statement and hypothesis will be conclusion. Sometimes conclusion will be hypothesis and hypothesis will be conclusion. Say for example, if the sum of adjacent angles is equal to 180 degree, when a ray stands on a this is. So, this is, and then if we interchange them, if we take conclusion to be equal to hypothesis and hypothesis as conclusion, what we will call it as? We will call it as converse. We will call it as converse. So, here what happens? If, then not, then not if. Say if, then instead of that, if not then if not if. So, here we can take that particular example. Somebody will say, go from Athani in one direction about 75 kilometers, you will see Gol Gumbaz, and if you see Gol Gumbaz, it is Bijapur. It is Bijapur. Then what they do? They go through 75 kilometers, but they will not see Gol Gumbaz only. Then what will say? When we have not seen Gol Gumbaz, it is not Bijapur. When we have not seen Gol Gumbaz, it is not Bijapur. So, no Gol Gumbaz, no Bijapur. Then is Gol Gumbaz, is Bijapur. See, means this is not and this particular convention, and that is known as reductio absurdum, or what we can call it as contradictory method. We consider something and finally what we say, we don't get that proper answer, then what we say, whatever we have considered first is wrong. But only thing is, there must be only two possibilities. If it is not there, then it is. Say for example, if we consider a number, if you say that the number is positive, okay, but you can have see, if the number is not positive, then it must be negative. You need not prove it. You need not prove it. If you prove that the number is not positive, then what it may be? No thinking. It is absolutely what? We will definitely say that it is negative. So, if only two possibilities are there, if it is not, then it will be. Then in that particular fashion, we can use this contradictory method also to prove certain propositions. Certain propositions. So, just again, proving yes implies R is equivalent to proving not R implies not yes. So, either you can prove in this fashion, yes implies R, yes implies R, or what you can say, it is not R, so it is not S. It is not R, so it is not S. So, this is known as contradictory method or absurdio dividendum or absurdum, you can say reductio ad absurdum. This method is called contradiction method. Contradiction method or reductio ad absurdum. Absurdum. So, sometimes you say in absurd, what do you say absurd? So means if you are taking wrong means absurd. So absurdum. Now we will be moving to proposition 2. Proposition 2. It is just you can call it as a corollary also in the old method. If OA, OB and OC are three rays such that OC lies between OA and OB, between OA and OB, such that and angle BOC plus angle COA is equal to 180 degrees, then AOB lie on same straight line, or what you can call it as collinear. AOB are collinear. So when they will be collinear, if angle AOB is equal to 180 degrees, already what we have learned. So here we go through that particular second method, that is contradictory method. So in contradictory method, what we do, we consider that they are not in line. They are not in line. So then we can go through that particular concept. So you can draw that particular figure. If possible, we say, if possible, what they be, let this particular AO be not in one line, not in one line. So you can call this as A and B. But if you produce this particular AO, then what it will be? It will be, they will be in one line only. So now here OC it is. Here OC. So what it is? OA, OB, OC are three rays such that OC lies between OA and OB. And angle BOC plus angle COE is equal to 180 degrees. What we have to prove? AOB is equal to AOB lie on the same line. When it is given only, see then, or it may happen in this fashion also. See, it may be taken this side also. So this is A, O and B, and this will be C. This will be C. So for this, we will be taking a particular construction. And what that particular construction is, produce AO. See, up to what? Up to D. So when we are producing this AOD is a straight line only. So what is the measure of angle AOD? It is equal to 180 degree. Or here also you can produce it. You can produce it to D. So let us call this figure as 1 and this figure as 2. This figure as 2. So what let us consider? If possible, AOB not in one line. If possible. So what we say? Proof. Proof. If possible. If possible, AOB be not in line or not lie on one line, in line. If possible, AOB be not in line. So what will we do? So what we will be doing here? Construction. Construction. What that particular construction is? Produce OA. Produce OA to D. Then what this AOD will be? So AOD will be a straight line or AOD lie on the same line. So then what will be having? Therefore, angle AOD will be how much? 180 degrees, because it is a straight line. But what is given to us? It is given that angle BOC plus angle AOC is equal to 180 degrees. So what is given? Angle BOC plus angle COA is also equal to 180 degrees. 180 degrees. So here if you go through these particular major conventions, major convention. So what this particular angle AOD, it is constituted of so many lines, or you can go through these particular concepts only. So now angle AOD must be equal to angle BOC plus angle COA. Angle AOD must be equal to angle AOD must be equal to angle BOC plus angle COA, because both will measure same. Both will measure same. So now according to first figure we will be writing. So according to first figure, according to first figure. So now according to first figure, if we go through this OC stands on this particular, according to first figure, see OC stands on AD. OC stands on AD. Therefore, angle AOC plus angle COD is equal to 180 degrees. So now this is also 180, this is also 180, this is also 180. So now we can write according to that convention. So now we will be writing, therefore angle BOC plus angle COA is equal to angle COD plus angle COA, angle COA. So now after cancelling these two, so both are. So now what we will be having, angle BOC is equal to angle COD. Angle BOC is equal to angle COD. So when these two angles are equal to each other, and these two angles are equal to each other, what we can say, you can write down for that angle BOC also. So therefore angle BOC is equal to angle COD. So when we will be having so many concepts, OC and OC here, D is there and B is there. So what it implies, OB and OD coincide with each other. Therefore OB and OD coincide with each other. Coincide. So OB will also on the D, therefore AOB lie on a line. So this is the proof of that particular proposition. This is the proof of that particular proposition. Or you can write down one more sentence also here. See this COD, what that particular angle COD is, it is equal to angle ODB plus angle BOC. But one more BOC if you cancel, then it will be, what happens, that angle BOD will be 0. So you can write down here, that is angle BOC is equal to, what that angle COD is, that is angle BOC plus angle BOD, plus angle BOD. So these two cancel out, therefore angle BOD will be equal to 0. And when they are 0, OB and OD coincide, so angle OAB lie on a line with